Welcome back to my video slideshow series. I am going to jump right into the server portion of this application and we will discuss the backend. So let's jump into it. All right, so here we are in VS Code, and if you take a look at this on the left-hand side of the screen, these are all the files and folders that are involved in making this thing work. The first one to look at here is the one that's just called Backend Server. This is the meat of the processing that has to happen on the server itself. So we're going to start here, and I'm going to work from the inside out. So the first two things, the first thing to cover here on the server is you'll see how I organized all the files and folders. The way it's split up is there is the server itself, which just contains the main.go file, and it has all the logic for all of the different routes and their handlers. Their handlers then talk to a couple different packages that I kind of created that are just in here just for organizational purposes. They technically don't have to be this way, but to me, it makes more sense to organize it. So we have the PhotoDB package, which is the database. Inside of the database here, we can go through each one of the individual pieces. This is essentially just a bunch of functions. All of these functions are used by the server package to write to the database, update the database, read the database, things like that. So you can see here I'm using SQLite, and I'm using a package by Matten, if I'm saying that right. And the very first thing we do here is create a struct, and it is just a database. It holds a reference to the database, so that way we're not creating it over and over and over again. I've created another type here called photo details, which is the information about a photo. This is essentially what's stored in the database, and it's what gets returned when we return information about a photo. So you get name, time taken, and last viewed. So name is actually like the file name, and that's how we reference it in the browser to get to load the actual image. I have a function here called initDB, and this is what will create the database if it doesn't exist. So when this thing fires up at the first place, since it's SQLite, if the database doesn't exist, it's just going to create it and it's going to build out the tables. The slide this over a little bit here. So the tables are pretty straightforward. I've created a table called photos, and it has fields for file name, last viewed, and time taken. That's pretty much all that needs to be in there. Then I've created a photo semaphore here that has the last poll timestamp. So the last time, I actually don't even think I used that. So whatever, it's just, whip this thing together. If these tables exist, this just nothing happens. So that's the easiest way to go through creating a database. Then I created a add photo function. Add photo inserts into photos. It adds the file name, last viewed, and the timestamp. So when you add a photo, you pass it the name of the photo and the time taken, and then the rest just gets populated in. This doesn't actually take the photo itself. The photo is just stored in a directory, and the name matches up. So the name of the photo is stored in the database, and the name of the photo is the file name in the file system for displaying it later. Then update last viewed. This is, again, you give it the name of the file, so the names are all unique in the system. And whenever you pass it the name of a file, all it's going to do is find the record in there. So we're going to update photos, and we're going to set last viewed to a value where the file name has a value, right? So I'm going to get a statement here. We're going to defer the close of the statement, and then we're going to execute this, right? And we're going to pass it the timestamp, the Unix timestamp. That's the first question mark, last viewed, and then the name, which comes in through the function, right? So this is essentially saying update photos, set last viewed equals now, and where the file name equals the name of the file. Then we commit the transaction, and that's it. So that's how you update the photo to show that it's been viewed recently. Next is the get next slideshow photo function. Now this is actually what the screen uses when when the big screen is running and it's pulling each photo. So essentially every time a new photo shows up on the screen, it's calling the server and saying, give me the next one. That's what allows it to automatically give you one that was just taken and then go back to scrolling through if none were just taken. So essentially it pulls every so many seconds. It just gets a new photo, gets a new photo, and it gets a new photo. This query is a little longer, but obviously still pretty straightforward. We're going to select the file name. We're going to select the last viewed timestamp. We're going to select the time taken from that photos table, and then we're going to select ordered by last viewed and say limit 1. So essentially, I'm going to get one photo, and it's going to be the one that was viewed the longest ago. Where if a new photo gets added in, the timestamp is 0, and since it's all epic timestamps, 0 just means a long time ago, and so it'll always give you that one. Now, since this is a query here, and I even since I said limit 1, it doesn't really matter. You still have to say for each one of the rows, blah blah blah. We're going to scan the rows, and we're going to return the photo details. There's only one record in there; it returns it out. We got a little bit of error handling down at the bottom here, and then this piece which you should never get to, which is returning an empty set if nothing happens or if you got an error. All right, so let's move on to photo processing. This one was a little bit more complicated. I had to be able to convert the photos that were taken on iPhone where nobody had messed around with their settings, right? And they were just using the HEIC file format because in Apple's infinite wisdom, they've decided to use a file format that is not supported by any browser. Like no browser, not even Safari supports it. So the way I figured that I would do this, there are a couple ways to do this, by the way. You can convert these things in JavaScript on the front end, or you can convert them on the server side. I decided to go server side. I'm using a package called GoHeic, and this was a pain in the ass to get working, by the way. So one of the things that you'll notice here on the left-hand side, I do vendor everything, which means I'm pulling all the dependencies actually into my code. And one of the things that I had to do on this was pull this entire package into here, because otherwise you don't get this libde265 folder. It doesn't come in when you just say go git. I'd actually download it, put it in this folder, then everything works. This is a bit complicated what it's actually doing here, but essentially we had to be able to extract the photo to a Go type of image, and then extract the Exif data from that photo so I could get the timestamp that it was taken. And then since I had an image and I had a timestamp, I could then convert it to a JPEG. So the function up top here, HEIC to JPEG, it uses the built-in packages. So GoHeic extract Exif, and then GoHeic decode, which takes the information, pulls out the Exif data, and then decodes the photo into a image type that's supported by Go universally. Then you have to write to a buffer that supports the Exif data to be able to make it something that you can use, right? Now, all the examples I found on the internet for this all had to do with converting one file type to another file type, HEIC to JPEG, right? And you started with a file and you ended with a file. And I didn't want to do that. First off, I'm not starting with a file necessarily. I'm starting with post data. And two, I didn't want to write the file. I wanted to return it where then I could handle all the file writing universally, whether it was JPEG or HEIC, whatever you want to call it. So essentially, the way this works is you had to create a buffer here instead of a file that everything could be stored into. Then you create this new writer Exif. New writer Exif gives you a type that we're creating here called writer Exif, and it's IO writer compatible. So it returns something of type IO writer. And what this is doing essentially is taking your buffer and writing the Exif data and moving the buffer pointer to the point where it's past the Exif data. And then it's returning that writer back. So back up here, what we're getting back is a buffer that's in the right spot to be able to write the image, right? So then what we're doing is we're saying JPEG encode, and we are writing to W what it returns, which is actually this buffer. And then it writes the image onto the rest of that. So all of this to say, it's going to receive this multi-part .file, which is what gets posted to the application, and then it's going to return a generic byte array of data, which is the image data or an error. All right. And then image convert. This is just got some helper functions in here, right? So detect and convert image. This is what's actually going to tell us if the image is that HEIC file image or if it's a JPEG. And if it's not a JPEG, it's going to convert it to JPEG. And if it is a JPEG, we're just going to read it. So either way, all said and done here, we're getting an array of bytes. And that makes it so universally, I've got an image file here that's an array of bytes that I can write somewhere, right? So it returns that information. Next thing we're going to do is we're going to decode that byte array into an image. So this is actually just going to give us a image.image. Then we're going to decode the Exif data to get the timestamp out. Again, this is all being able to universally use this information, where before we couldn't universally use it because it was two different file types. Now at this point, it's all the same file type, and all this stuff can be used universally. So we're going to get the data out of it, and then we're going to get an orientation tag off of this. So if the photo's shot this way or this way or this way, which is 3 different ways to shoot a photo, it will know which direction it is. And I had to do a lot of digging on this to figure this out, because the orientation is really, the value of the orientation is just a number, which is very confusing. So in the case where the orientation is 3, we have to rotate it 180 degrees. In the case where it's 6, we have to rotate 270 degrees. If it's 8, we have to rotate it 90 degrees. There are a bunch of other cases, but I just didn't want to support all them. They range, all the way around the bend. And then obviously I think it's case 0 or case 1 is where it's normal, just the normal direction where we want it, the way we want to display it in the first place. So we're just going to leave that alone. So essentially, we're going to use the imaging package, and we're going to rotate these photos. After all of that is done, we've rotated it and everything. We're going to return this image, which is image.image, and we're going to return the timestamp, then nil, which is the error. And that's all there is for that piece. So now that we've got the photo rotation and the image conversion all set, and we've got the database in order and the things we can call with the database, now we can go look at the server itself. And this is essentially the piece that defines all the routes and makes all this stuff available to be used on the web. So over here in server, all I really have is main.go. And if we go to the top of this file, I've got a couple environment variables that I set up. So you have the session secret and you have the application password, right? These are the session secret is essentially just a hash, and the app password is the password that the user is going to type in order to be able to log into the application. I'm using Gin here, Gin Gonic, which is just a very kind of simple web server framework for Go. And it has some automatic plugins that you can add to it, or middlewares that you can add to it. And one of them is auth, and it just uses cookie auth. It's nothing really powerful, but it'll do the job here for this one-time use app that I've made. This is a pattern I like to use in Go. Like if I'm going to be making a bunch of routes and those handlers need to essentially be able to use shared stuff, I'll create a type and we will attach all the handlers to that. So in this case, I've created a type called routes, and it houses the database, the actual, an instance of the photo database. The next thing we want to go through here in main is just some setup. This actually runs every time. It's just it's idempotent. So it makes sure that it doesn't wreck anything. Essentially when it runs, it checks, and then if something needs to be done, it needs to be done, right? So I've identified a couple paths here, /data/photos and /data/database. This is where the photos are going to be stored and where the database lives. Later on, I will mount these to a persistent disk, so that way if we have any application restarts in Kubernetes, the data won't be lost. We're going to check to see if those paths exist, and if they don't, we're going to create them. That's the first thing. Then we're going to create the database instance, and we're going to call initdb, which we talked about earlier. Initdb will create the tables if they don't exist. If they do exist, it's just going to connect to the database and be ready to go with this instance. Now I'm going to use that type that I created up top, and we're going to say routes is a type of routes, and it has the database, and then I give the database instance. So that way all of my handlers here can share that database instance, and I don't have to reinitialize it or reconnect to it over and over and over again. Down here, we're going to go ahead and create the cookie piece. This is the cookie store for for Gin for storing the information in a cookie, the session information, and hanging on to the login. So I give it the session secret. That's how it scrambles the data, so you don't see it in plain text in the cookie. And then we're going to say r.use, which is part of Gin, and we're going to say to use this session store. So it's just going to have that and be ready to go anytime this stuff is used. Now, the next part here is just creating all these routes, right? Some of these routes make total sense right now. Some of them won't. You're just going to have to hang out with me until we get into the next part. But here we've created routes for ping just because this is just a health check thing, use it in Kubernetes. Then we've got some routes here that are namespaced into the API path. So API slideshow next is what gets us the next photo and just returns JSON data. And then here we're calling routes.getNextPhoto, which I'll go down to in a little bit. Here we have API/IsAuthenticated. This just checks to see if the user is authenticated already, and it won't then kick back an error and ask them to log in. API login is a post endpoint. The post endpoint will accept the password. And if it's the right password, it's going to set that in the session and then allow the user to access the application. And then you have API upload, which is where you send the photo information to upload a photo to this application. Further below that here, all these are all front-end related, right? So you have assets, which is front-end related. It's got images and stuff. You've got /photos, which is actually where the photos are mounted, calling the photos in the browser. Then you've got the root, the /login, /TV slideshow. These are all paths that are defined by Vue in the Vue application for the front end. And they all point to index.html because we wrote it as a single page application with routing. So it is always going to be index.html that's serving all of these routes. It's just using the internal router to show you the right thing. Here I'm just doing, I'm running this. I'm running it in a Go routine, and then we wait for it to exit. If it exits, then we log fatal and we error out and we close the thing. It's not super smooth, just whatever, it works. I use this function almost constantly in so many different applications. Getenv default, it's essentially just an extension to the os.getenv that Go offers, is for getting an environment variable. And what it allows you to do, if we go back up to the top here, is it allows me to say getenv default, and it's going to get this environment variable. But if this is blank, then it's going to set it to default secret. This just allows me to use this in dev without having to set this stuff. So it sets these values if there isn't one set. All right, so now into the meat of it, right? I've got the login function here. So this is routes.login. And if we go back up to the top here, you can find API login points to routes.login. So this is how Gin works. So this is a post route, and this is the path, and then this is the handler. So now if we go down here to login, this is what allows you to log in. So if the form value that's posted of password equals the app password that we've set from the environment variable, then we set the session information and we set authenticated true in the session, and we save that session. That session gets saved to the cookie. That's the way the cookie sessions work. And then we just return authenticated true as a JSON output. Again, this is built-in functionality of Gin. So c.json just says we're going to return whatever the status code here is. So status okay, so it's 200. And then gin.h is saying just this is going to be JSON data. So you kind of put your JSON in here and it spits it out. There are more advanced ways to do this where you can identify all of your JSON data as a type, and then you can marshal and unmarshal the data from JSON to JSON, whatever you want to do. But this was quick and easy, and it's really simple to do. If password doesn't match, then we're just going to return a 401, and we're going to say authenticated is false. IsAuthenticated is related to this. This is just a quick and easy way for the front end to check and see if the user is authenticated. It's going to call this on every page load just to make sure the user's logged in. If not, it's going to kick them out. So again, we're going to call this auth check, which is just a function that I wrote here for splitting this out. We're going to get the session information. We're going to get authenticated from the session. If that equals string true, then we return nil. Otherwise, we return not authenticated. So again, right? So if error does not equal nil, then we're going to return a 401. And if error is nil, we're going to turn 200 okay, and it's going to say authenticated true. That's all there is to that. That's the whole authentication piece, just to get a quick login. The function for uploading a photo is probably the most complicated one in the whole thing. Now, first off, you're going to see that I wrote a hack into this, and I might take this out. But essentially, I made it so, and this is for that application that's running on the laptop in the other room. Instead of apps, where people are on their phones, they can type the password. That's fine. But for this other little Go application that's just monitoring a folder and looking to upload stuff, I wanted to make it easy for that thing to log in, so it didn't have to go through the login screen and remember all that stuff. So essentially, what I did here is I just made it so it could be a query string. So if the query string if P equals the password, or in this case, I'm doing negative. So if it doesn't equal the password, then we're going to do a normal auth check and we're going to return 401 and all that stuff. But if it does, we're just going to move on. So essentially, this is a way to make this work really super easy. Just the password is in the URL of the post where it's sending the photo. Now we're going to get the file. So here, this is just part of Gin C form file. This is getting file information that's coming from the post. And we're looking for a field type called file. So that's just the name of the field on the front end. And then if there's no error with getting this, then we're going to skip. We're just going to keep moving. But if there's an error, then we're going to return an error saying that the file upload failed. Next, I run all of this in a Go routine because the user doesn't technically have to wait for this to finish. So we're just going to run all of this in the background and tell the user everything's fine. It might fail in the background, but I figured, what the heck? It's no big deal. So here inside this Go routine, and keep in mind that the user's not waiting for any of this to finish. It immediately will jump here to status 201. So essentially, if we were able to get the photo, that's it. The user says, cool, success. But in the background, what's happening is we are using that photo processing package that I talked about before that says detect and convert image, right? So this is taking the file, and it's going to return, go back to here to detect and convert image. It's going to return an image and the timestamp and an error, which is hopefully null, right? So back to here. So we give it the file. And so we're going to get back the image and the timestamp and the error, right? If there's an error here, we're going to log the error and we're going to return. Again, this is in a Go routine, so I don't need to return anything to the browser. The browser's not even there anymore. It's not listening. So essentially, just move on, give up on this one. That's what's happening here. Next, we get a timestamp that's got the Unix, it's a Unix timestamp with milliseconds. And then we create the file, which has got the timestamp as the file name. All the way down to millisecond time because I didn't want collisions with people uploading photos. There's still a chance with milliseconds, but not a very good one. And then we're going to set the JPEG options to 90%. I didn't really see the point doing 100%. You gain so much in terms of file size difference just by setting it to 90 instead of 100. It's amazing, and nobody notices the difference, especially in a party. Who cares? So JPEG encode, we're going to encode this file now to an actual JPEG, and we're going to write it to the out location, which is created here. This is the file this is the file pointer. This is the file itself, and these are the options. Straightforward. This is JPEG encode built in as a built-in package for Go. Again, if we get an error, we're just going to bail because the browser is not listening right now. The user can get no feedback from this. Then the final thing we're going to do after we've successfully taken the file, put it in a folder with the right file name, we're going to add the photo to the database. So we use the database, which is on R here again. So all of these functions are part of the type R, which is our routes, right? So routes. So back down to here, we can see func R routes. This is referencing our routes type that we created. So r.database, and we add the photo. This add photo function is looking for the file name and the timestamp. So we give that information and it writes it to the database, and then we return 201 because 201 stands for created, and we're all set. But again, 201 created has already been returned at this point. It just got returned to the user that said we're all set while the server chunked along doing all this processing and converting and stuff. Here's my ping, very straightforward. C.json, return message pong, that's it. And then get next photo. So this one is the one that is the handler for returning the information for the next photo. And we got r.database.getNextSlideshow photo. This is going to return the information for the next photo. Then we're going to call the update last viewed with that name that we just got. So we write into the database, hey, this one was just viewed, and that way we don't show it again. That's what it's using to determine what photo gets shown next. And then we're going to extract the name out of here, and then we're going to return P, which is the information about the photo. So back to this one again. So this p.name, we're updating the name to be the actual path to the photo, so that way I don't have to do it later. So essentially, it's going to return the full path to the photos. That way, the front end can just go for /photos/timestamp.jpg, and and it just works. That is the whole backend. That's the entire thing. So there you have it. There's the whole back end of the application. In the next part of the series, we're going to talk about the front end, which is written in Vue.js, and go through each one of the screens and the routing and the individual components. See you next time.